How do you keep 30 Kubernetes clusters running across 4 regions, serving 300,000 requests per second on 2,000 nodes without burning out your team or blowing up your budget? In this episode of KubeFM, we welcome back Thibault, who's head of runtime at Adevinta, for his second appearance on the show. Thibault takes us inside the engineering realities of running SHIP, Adevinta's multi-tenant Kubernetes platform, and unpacks a fascinating incident where the Vertical Pod Autoscaler went rogue, evicting critical system pods in a continuous loop. We'll talk about why resource management at scale is a nightmare without VPA, the architecture behind its recommender, updater, and webhook, and how client-side throttling in the Kubernetes Go client triggered widespread failures. Most importantly, Thibault shares how his team debugged VPA source code to uncover hidden limits and fix the issue in production. Special thanks to TestKube for sponsoring today's episode. Need to run tests in air-gapped environments? TestKube works completely offline with your private registries and restricted infrastructure. Whether you're in government, healthcare, or finance, you can orchestrate all your testing tools, performance, API, and browser tests without any external dependencies. Certificate-based auth, Certificate-based auth, private NPM registries, enterprise OAuth, it's all supported. Your compliance requirements finally met. Learn more at testkube.io. Now, let's get into the episode. Very nice to have you back with us for the second time on the podcast. As we get started, want to know about what 3 emerging Kubernetes tools you're keeping an eye on.
So today I would keep an eye on Crow, which I think is a nice orchestrator and then pretty much allows you to abstract Kubernetes resources in an easy way. Then obviously, if I didn't quote anything around AI, it would be a shame on me. So obviously, I would keep a look at MCPs and finally, because of the scale that we have, I'm super interested in keeping following cluster API, vCluster, and the different opportunity that it gives. So those 3 tools: Crow, cluster API, vCluster, and MCP servers.
Very good. Well, we did have you on a previous episode, Thibault, but I just want to know, for folks that don't know you, can you tell me about what you do and where you work?
Yeah, so I work at Adevinta. We are basically a marketplace group here in Europe. And I'm actually running the runtime of our platform. So it's based on Kubernetes, and we currently have around 30 Kubernetes clusters. We have peaks of about 300,000 requests per second and around 2,000 nodes. So significant scale. And yeah, we have to actually deal with very different sizes of clusters, but I think that we will come back to this a bit later.
Very good. And how did you get into cloud native?
Well, I started as a software engineer in embedded imaging, and because I was writing in C and a company based in Paris needed some C developers, I made the switch to the web at the beginning. And then I got attracted by Docker in that time, and then slightly shifted towards infrastructure. And a few years after, they asked me if I wanted to become SRE or DevOps. And I said, yeah, let's combine all of this together. And that's how I'm in.
And what were you before cloud native?
Well, I was a backend developer, as we just said, right? So I was a backend developer. I was coding in C and then in Go. And even before then, I was embedded developer. So I was doing some stuff for mobile phones. Actually, the code that I was doing was shipped inside a microcontroller, inside a sensor, inside a mobile phone. So pretty much inside. So super small. And then we're talking now about pretty higher scale stuff. So very interesting way from there to here.
The Kubernetes ecosystem moves very quickly. How do you stay up to date? What works best for you?
Yeah, it moves pretty fast. There are many sources of information from blog posts to newsletter. I'm following a bit Pragmatic Engineer, if you know about it. I also have a TLDR newsletter that I'm following. Also, Medium feed where I select and pick the articles where I have the most see the most interest. And then obviously, like I have my teammates that provides a lot of information to also have their own channels. So that's a bit how I keep updated with the community. Not talking about GitHub, obviously, because often you have a lot of information on GitHub.
Very good. And if you could go back in time and share one career tip with your younger self, what would it be?
Well, I think it would be the same as last time, right? So it's not all about tech, and the more I grow up, let's say in my career, the more I realize that it's definitely not all about tech, and it's probably less about tech than about connecting humans, connecting people to actually do the job, right? That would be my advice. And obviously, the older you get, the older it is to actually change yourself.
Well, as part of our monthly content discovery, we found an article that you wrote titled "When Vertical Pod Autoscaler Goes Rogue: How an Autoscaler Took Down Our Cluster." So we want to dig into this a little bit further. The article describes a fascinating incident at Adevinta where their Vertical Pod Autoscaler caused widespread pod evictions. Can you start by giving us some background on Ship, your Kubernetes platform?
Yeah. So Ship is actually the runtime of the platform. We have some other components around it, but it's the runtime. It's based on Kubernetes, and as I said in the beginning, so we are running around 30 clusters. We are running in 4 regions. We have thousands, 100,000s of pods, and we serve around 300K requests per second. But we have a very dispersed usage of those clusters, right? And this is something that is probably not that unique, but it's pretty significant in our setup. So we are multi-tenant, and we have some clusters that are smaller, some clusters that are bigger, and we serve marketplaces mostly in Europe.
And with a platform of that scale, resource management must be incredibly complex. And we've also noticed that in our monthly content analysis, that the topic of resource management keeps appearing again and again because people have a higher demand for that content to learn about it. Why is VPA so critical for your operations?
Look, before we had the VPA, we were in a pretty lower scale, and yet, resource management was a nightmare. Was a nightmare for mostly 2 reasons. Is that resources, like the needed resources, they evolve over time. So you don't really know how to get the best balance between cost efficiency. So you bin pack more in your nodes, so you have more posts scheduling on your nodes. You have better nodes to fit the actual workload that you need to run. But also, like across the fleet that you have, then you have sometimes clusters that need more resources than others. So you would end up either going for the maximum, and then you waste resources in the clusters that are smaller and require less resources, or go to the like an average, and then you have problems like performance problems or even stability problems on other clusters. So mainly 2 things, right? So you have a disparity of the cluster sizes and the cluster needs, the component needs. And you have also the evolution, and you have to come back to the resource management over time, over and over again. And this is actually training in terms of engineering.
You mentioned that VPA has 3 main components. For folks out there who might not be familiar with VPA's architecture, could you just give us a quick walkthrough what each component does and how they work together?
So in VPA, there are indeed 3 components. So there is a recommender. The recommender is here to analyze the resources usage. So we're talking about CPU and memory usage of each individual pod from usually a deployment, right? And it measures this over time. Based on this analysis, it will provide the best resources that the pod would need to run properly, but not to be oversized, right? That's the recommender. Then you have the updater. The updater, when it detects that a pod is not matching the recommendation, it will evict the pod. It will just tell the Kubernetes API, this pod needs to go. So the Kubernetes API will remove the pod and create a new one. Better say, we create a new one often and remove the old one. And finally, you have the mutating webhook. And this mutating webhook is the one responsible for when a pod is coming in, when the definition of the pod is coming in, it matches basically the recommendation, and it says, hey, I need to replace the resources for this specific pod for every single container, so that it matches the recommendation. So it's an in-flight basically request that changes underneath, and the definition of the deployment that actually controls the pod is not changed.
The incident started with what seemed like a routine Prometheus alert and about missing metrics. How did this seemingly minor issue escalate into something much more serious?
When we received the page, as we sometimes receive, we try to automate everything that we can and to stabilize everything. But sometimes you have a page, and we received the page because somehow some Prometheus that are best effort storage was failing to be scheduled properly, and there was some memory exemption, and it was all killed every now and then. So we said, okay, there is something wrong with that. Maybe it's because of the nature of Prometheus as well. It's collecting a lot of data, and maybe there is something wrong with this specific cluster. That means that that makes that the pod is actually not, or the Prometheus metrics are not behaving properly. And maybe it's now, but maybe it's in the past, right? So what we did is to first consider that this was the problem, something with maybe the history. So we, as a classic measure, because it's the best effort storage, we deleted the PEC, so the volume that contains the actual Prometheus data, to start from scratch. Said maybe it's going to fix it, but didn't solve really the problem, right? So at this point, we said, okay, it's not necessarily just a Prometheus problem. And then we started to see that the amount of pods being evicted was growing up, right? So it was growing up, and we say, maybe it's also related. So let's see if there is something wrong also with VPA. So we were starting to look at this configuration. And then we say, okay, we actually stop VPA from recommending. We manually fixed the size of the Prometheus, and it was kind of okay for a few hours. We said, okay, that looks good. Until we have the next page, right? You know how this is, right? So you think you're pretty much stable enough to go for the night, and then you receive the last page that says you're not gonna go through the night. So you need to go the next step.
And you discovered that the evictions were happening in a continuous loop, affecting critical system pods. What was your initial hypothesis about what was causing this behavior?
We were trying to understand, and one of the things, so we had the first hypothesis, which is that, okay, we have a churn in terms of number of pods, and this would actually, because of the churn, then you have more metrics generated, and this would escalate down to Prometheus, and then BPA wouldn't have time to provide the relevant recommendation to scale up. So that was the initial suspicion. And then the second suspicion, when we saw that, okay, this is spreading across multiple pods, is that there is something wrong with the recommender, right? So we actually turned off the recommender and used static sizes. But in the end, after a while, we saw that this wasn't the source of the code. So we had to keep digging.
Looks like the investigation took an interesting turn when you started debugging the VPA components directly. What specific discovery made you realize that you were looking in the wrong place?
We didn't understand what was going on, because everything is automatic, right? It's automated, and it happens in milliseconds, and you don't see that, all right? So one thing that we decided to do is actually to pull down the actual source code of the VPA, the recommender here. And we wanted to understand why it was evicting, or the updater. So we run the updater, and we said, why is it considering to evict? Because we think that it shouldn't evict, right? And then we realized that it's because it was missing, that the pods were missing some labels or some annotation. I don't remember which one, but it's not very much a big deal. And after rezoning a tiny bit, we said, oh, but those annotations, they are actually they're actually injected by the mutating webhook, right? So the mutating webhook actually says, hey, I inject this, and this is a sign that I consider this pod, right? And then it usually works in harmony altogether. But then all of a sudden, because that this mutating webhook was not doing the thing, then the recommender or the updater here, the updater would say, hey, webhook didn't do, or this pod was created before the webhook was running or whatever. So I need to evict this pod to get actually the thing applied. But because webhook was not working properly, then it would come in again without, and then updater will keep deleting the pod, right? So that's where we said, okay, the reason is we don't have the labels, and this is by entering in debug. So we provided all the setup to run in debug. We provided updater read only, so we know that we are at least not doing any changes on the infrastructure side. And this allowed us to put the finger on, okay, this is the reason why pods are getting evicted, right? And then while working through, right, we saw some stuff that was in our head, but we didn't like jump on it, and I think we're going to see it right after. Huh?
The webhook failure turned out to be a critical clue. Can you explain why webhook latency of over 20 seconds was so problematic, and what made this particularly challenging to diagnose?
It was actually problematic because then pods are slow to be scheduled, and in some cases pods are actually replaced, right? So this was degrading even more the quality of the service. So in most of the cases, it's I create a new pod and I remove the old one. But in some cases, especially the Prometheus one, it's I remove a pod and then I create a new one because it needs the volume. So that means that there is a downtime because the old pod is removed, then the new pod is created, and it lasts 20 or 30 seconds for the webhook to actually fail. And because in VPA there is a failure policy of ignore, and this is not customizable, or at least in the version that we had, it was not customizable. Then we went for the actual timeout, and we would generate downtime, and every time that there was an eviction of the pod, then it was even creating more downtime. So that was the thing. And then what we also went for is to analyze, okay, when is it evicted? When the pods are evicted and when there is a webhook failing, right? And we put them together and we say that, oh, but every time there is a surge of pod eviction, every time, then there is a webhook failing. So this even pointing more to the idea that webhook was failing somehow and generating more downtime every time.
You mentioned trying to fix the issue by adjusting flow schemas for API server capacity. Why didn't this approach work, and what led you to look elsewhere?
Yeah. So basically, yes, what we saw when we were in this investigation looking at things, right? We saw that there was a throttling somewhere in the logs, right? So we were fruited by logs from the API server. But then at some point we saw like throttling and people API server and PA. So we were looking at both. And in a webhook we saw throttling. And then we say, hey, but maybe it's because there is there's too many people accessing the API together. So we decided to actually give it a full capacity, right, with flow schemas. But this didn't help. And if we rewind a tiny bit about what we were saying, we actually were looking at the code, and by looking at the code at some point, we had a breakpoint, or we went through the command lines argument for the actual webhook. And we saw something interesting there, some arguments that say, hey, but there is not only the API server that throttles, there is also client-side throttling. And this is where we said, hey, we need to also look at this.
The breakthrough came from debugging the VPA source code directly. What hidden configuration did you discover, and why was it so hard to find?
Yeah. So actually we were noticing throttling, and we completely forgot that the Kubernetes client, the Go Kubernetes client, has some client-side throttling. And those two, there are two parameters that by entering the debugger mode and looking at the source code, we saw them, both of them, Kube API QPS, query per seconds, and Kube API burst, right? And surprisingly, the default values are pretty low for such components, right? So if I remember correctly, it's around 5 and 10, so 5 requests per second and 10 requests per second burst, which is pretty low. And it wasn't very well documented in the Helm charts, right? We couldn't see it like very explicitly. It's probably, if I remember correctly, some extra argument that you need to provide. So it's not in the Helm chart values. And to understand it, you need to run in the dash-help, right? So you need to pull the image and then run dash-help, and you have the actual. In our case, what we ended up doing is just seeing it in the code, and that's pretty much the equivalent of running the image with that dash-help.
Once you identified the rate limit issue, the fix seemed remarkably simple. Could you walk us through what you changed and the immediate impact it had?
We just raised the QPS and the burst rates. I don't remember the factor, but probably put it a factor of 10 or 20, something like that. And instantly, in less than a few seconds, everything got resolved. So webhook could work again completely flawlessly, seamlessly, and everything was resolved. All the alarms were resolved, Prometheus stabilized, everything was clean. So just changing some 2 parameters to fix the problem.
Looking back, you discovered this problem had existed since July, but only became critical recently. What changed in your environment that turned a dormant issue into a crisis?
Yeah, well, basically, it's always this problem about slow scaling, right? So we had increasing problems, but probably it was happening, and then because it was self-healing at some point, problem disappeared, and we didn't even have time to get patched, right? So it's a combination of multiple factors that makes that the scale basically reaches a certain threshold, and we needed to have like more pods at the same time, and then it just escalates in a vicious circle that makes that this change actually this specific time was the time that was selected for the problem to happen and to manifest, creating this incident, right? But yeah, it has been degrading for a month, and we could see it on the graphs. Right? We could see that we had timeouts on the webhooks for several months, but it wasn't that much of an issue at that point, or we didn't think it was that much of an issue at that point. But it happens that in reality, probably it was.
One of your key takeaways was about not fixating on recent changes. How has this incident changed your approach to incident response and root cause analysis?
One of the first thing that we did actually to investigate this incident was to say, okay, because it happens now, there must be a change that we've done today or yesterday that triggers this problem, right? So we started to revert some of the changes that we did to say, okay, let's see if this is the case, right? And we went for this for a few hours, right? And we said, okay, it must be something like that. So we were a bit not blind, but focused on this in particular, and completely forgot that there could be some degradation in terms of quality of service that could actually at some point reach a certain threshold to make it work, right? Funny enough, VPA is also VPA by itself, right? So we also have VPA to update itself. So this probably didn't help, right? I think if it has to be done again, we would do it again. But yeah, the basically, I think one of the big lessons here is indeed you need to understand what has changed, but don't focus on what has changed, because eventually it's something that is not necessarily today that was changed, but it's something degrading, and there are some parameters that you don't understand. So trying to understand the problem and fix it rather than trying to spot exactly a specific change that often doesn't happen or didn't happen.
You mentioned that webhook failures are silent killers in Kubernetes. What monitoring and alerting improvements have you implemented to catch these issues earlier?
Yeah, so we're constantly updating and improving our monitoring. Obviously, we have some newer monitoring in terms of web latency, web failures. We have failure rate also alerts, so we understand where that. Okay, some failures is okay, but too much failure is definitely not a good thing, right? And any webhook failing is actually a problem now for us, right? Before it was like, okay, if the rest is working, is good, but now if one of our webhook is failing, we say we need to take a deeper look into this, because eventually this is going to escalate somewhere.
The ability to debug open source software was crucial in solving this issue. Is there any kind of advice that you would give to folks out there, to teams about building this capability?
It did help us significantly, and this is, I think, the point where we pivoted from basically, okay, there is something that has changed, to understanding the actual source of the problem, right? And obviously having a white box that you can open and check, that helps a lot, and it actually helps us to speed up the resolution, right? If not, we would have taken way longer if it was a black box. So it's always, in my view, it's always a good thing to understand how the components that you're installing in your clusters, in your infrastructure works, what they do, what they don't do, and how they actually work together to provide the value that they are delivering, right? Because then, if it's working, you don't have to care about it, right? But the day it starts failing is the day that you will say, hey, I better know, or I wish I knew how it was working, because it would save me a lot of time.
Looking at the bigger picture, what does this incident teach us about running autoscaling systems at scale, especially in multi-tenant environments?
Autoscaling is great because it provides you basically the relevant trade-offs, right? So you can tune the trade-offs to have good stability, but also good cost efficiency, and good response time, right? So that's when it works well, it's amazing. But it also teaches us that autoscaling, it needs to be finely tuned and works very well. If it starts to fail, then you're probably in a big trouble, right? You're probably gonna experience issues. So this is a major component in your infrastructure that you need to look after, and just don't neglect.
And if other teams are running VPA or similar autoscaling solutions, what specific configurations or monitoring should they check based on your experience?
Okay, understand very well what the recommender says, what the recommender does, so that they can troubleshoot more easily, right? So the recommender, the recommender itself has an object that you can inspect to understand what is the history, what is the recommendation, so you can understand which parts of the whole system is actually failing, right? And look at all the metrics of the cluster, right? I know that there are a lot of metrics, and sometimes you get lost about it. But in particular, look at the webhooks latency. The webhook latency, it should be pretty low, right? And we saw it also in the previous talk that we gave about providing ARM, right? So we want the webhooks to be extremely low, so you don't affect the scheduling of the pods, right? It's especially for pods or the deployments, right? If the webhooks get slower, then you slow down your whole platform, right? So you want them to be extremely fast. So understand what is the webhook latency. Understand okay, how often do the VPA in that case, but it could be something else, evict spots, right? Probably this is going to be re-architecture, right? Because now there is in place upgrade, in place edit of the resources with the newest Kubernetes version. So maybe the architecture is going to change a tiny bit, but meanwhile, it's this architecture. Understand basically how often is there eviction. If this changes dramatically, then you have something to look at, right? So the eviction rates and monitor very well the health of the VPA itself, right? Especially if you VPA the VPA itself. And in our case, we do because we have we have a huge spread basically of the different clusters. And sometimes we need very small VPAs because we have small clusters, and on the larger one we need way bigger VPAs. So with VPA itself. Yes.
Finally, after pulling an all-nighter to solve the issue, what's the most important lesson that you and your team took away from this experience?
So the first one is know the system that you're running, right? It's super important. It's not just Helm install and it works, right? Okay, why it works? That's super important, and how it works. There is no magic inside, right? And here, basically, this article that we are talking about right now, I wrote it with two of my colleagues, right, Tanat and Fabian, and both of them, we were actually awake for a significant amount of time at night when we had the last page to understand what was going on, right? And it was only this combination of all of three looking at it, this collaborative debugging that bring us to this solution, right? So that's something that is that was also significant inside it, right? So collaborative debugging and understand very well the system that you're dealing with. Right? And finally, don't assume that there is a casuality about what you did today and the incident that you're having today. It's a good thing to take a look, right? But take a look at it thinking that, yeah, confirm or infirm, right? But don't start with the assumption that this is something that we did today that causes this incident or this problem in production, right? Because eventually you're going to miss some opportunities. So be open-minded. It can be usually anything. Discard the different problems that could be related to today, but then look at other ones.
What's next for you?
Yeah, so what next for me? We're still delivering on our platform at the moment. I believe that there's going to be some time more, but I'm already preparing the next step. I don't know if it's going to be still in platform engineering as I'm doing right now. I'm going to come back to backend development, or maybe something else. I don't know right now. Photography, why not? Something else. We'll see, right? But yeah, I expect that there are going to be some movements within the next year. I mean, the platform that we've done is great. It's running very smoothly right now. So let's see.
Just want to talk about the subject of photography. It's something that interests me a lot too. In the beginning, you mentioned how, as much as we can talk about the technical issues that go on, there's very much, the personal side of things. As much as photography may seem like a technical exercise, what are the non-technical aspects of photography that you think some people might not be aware of?
Ooh, that's a good question, right? Actually, so us as engineer, we like to look at anything on the tech, the tech aspect of everything, right? And yeah, it's true, right? There is a tech aspect, but you don't need a camera that is the latest one to do great photos, right? There are tons of photographers that did great photos, amazing photos that are still extremely relevant today with gears, with tech that is way lower than what we have, right? So there definitely is something different. This something different is observe, connect with people, right? Connect with the atmosphere as well. It's not necessarily only about people, but it's also with the atmosphere. What is the story that you want to that you want to tell? What approach you want, right? And the way you approach a certain scene, the it's going to influence a lot your photography. It's about all of this, right? So there is a technique. There is a pure technical technique, right? So the quality of the frame. This enables you, yes or no, to do some photos. But then you have your photography technique per se, which is, okay, what do I observe, right? So the main thing is the eyes. What do I do observe? How do I compose a frame? Then understand basically how people are interacting, behaving inside this scene. What is going to happen to anticipate and get the shoot right? And there are many photographers that actually tell you that, and this is still in the technical aspect. You see how hard it is for tech to get out of the technical aspect. But there are many photographers that say that, hey, I observed this place, and I knew that I could do a photo here, and I came back every single day for 1 year, 2 years to actually wait for this photo to be taken, right? So there is this, and there is also how you interact with people, right? So how you, it's often even non-verbal, right? So the way you behave invites or not people to ignore you because you want the scene as is, or to completely hang out with you to have some lighter environment sometimes.
And how can people get in touch with you?
Many ways. So my LinkedIn, I guess we're gonna have the links below, right? But yeah, you can reach me on LinkedIn. On Medium, we're starting to also share more about what we've been doing the last years on Medium. I'm a bit on X as well, X Twitter, and Instagram. If you're more into photography, I tend to preserve my Instagram for pure photography things.
Fantastic. It was wonderful having you back on the podcast. Thanks for being so open about sharing your experiences so other people can learn from them, to maybe not make the same mistakes, or to keep these things in mind if they're encountering issues, whether it's with webhooks or autoscaling. Very nice to talk to you, Thibault, and look forward to speaking to you in the future. Take care.
Thanks for having me. Thanks.